Captain Larry, W6WUH, working on the Rogers Black Widow. You know, every once in a while you encounter a problem with a radio that just stumps you, drives you nuts. And that's been the case with this one. This one transmitter failed during bench testing. I had it hooked up to a dummy load, 50 ohm non-inductive carborundum resistor dummy load in the watt meter, and pumping out 15 watts, tuning just fine, modulating just fine, looking at PEP output going up to close to 50 watts. Everything just fine. And ran, we were testing that way off and on for half an hour or more. And at some point I went and took the louvered lid and set it on the top, and something went, and the output dropped down to 2 watts. And no obvious reason for that, no arc path, no, probably coincidental, but I've been working on this thing off and on for a week and thinking about it the whole time, trying to figure out what the heck is going on. And I've got myself a list of, 10, 12 possible things that can cause the RF output to go low, and I've checked them off one by one, just the way you should. First thing I thought of, well, either the tubes, blew the screen out of the final amplifier tube, or the modulation transformer went bad. Took all the tubes out and tested them. Everything's fine. Changed the 2E26 by substitution, just in case, same result. Bypassed the secondary of the modulation transformer. Actually, I measured the primary and secondary. Everything seemed fine there, no shorts to ground. Jumpered across the secondary, so if there was some big voltage loss there, or if there was a carbon arc path inside the transformer, then it wouldn't carry the current. We'd find out by jumpering across it. No change. Worried about low grid drive. Measured the tube on the tester. Changed the tube by substitution. Jumpered across the coupling caps between the doubler and the grid of the 2E26. No improvement. Jumpered across the first and second stage of the oscillator and doubler. No improvement. Measured the screen voltage, 200 volts, just like the book says. Nice big fat resistor there, measures right, no sign of it getting cold. The thing uses this coupling, probably should get the, it's inductive coupling between the tank circuit and another tunable circuit, separate coil and capacitor that are not electrically connected. So this little coil and capacitor connected the antenna. The other is a tank circuit. I think it's called a Pi-L circuit. So I was wondering, these two are sort of supposed to be glued together, a little loose. Keyed up the transmitter, used something insulated, push them together as close as they could go. No change. So then I wondered, okay, how about this little feed-through capacitor down here, where the B plus passes from the bottom of the chassis through a feed-through capacitor up to the top. Measure the voltage on both sides, no change. Even jumpered around it, no change. Back to the list. The one thing I haven't been able to check, and it's about the last possible suspect, is this bypass capacitor This down here you can see, I'm going to get a little more light on it. Very difficult to see in here. Down in there is there it is, the RF choke. So the B plus comes up from through the chassis from the bottom to the top, through that feed-through capacitor, runs through this RF choke, goes over to this standoff where there's a little ceramic RF bypass capacitor to ground. And then the other end of that ties to the bottom of the tank coil. So if that capacitor failed, it could shunt the RF from the tank coil. If it was very leaky, it could shunt RF from the tank coil to ground and cause the output to go down. So that's about my last possibility. Let's go back to the list. What else did we look at? Bad tube. Tested the tube fine. Substituted another tube. No change there. Is it possible that the oscillator doubler's operating on the wrong harmonic? I got to get a receiver or a frequency counter and check that, but it's not too likely. I think that the tuning is all normal, first of all, and the readings on the meter are pretty normal. I'm wondering if the output from the oscillator or the doubler is low, but the grid drive seems to be what it was before. No way to test the neutralization, and not really aware that it's got any. Bad cable, bad connector, bad power supply. Substituted them with others. Went back to the bench supply here instead of using the modified HP23. Took the cable that I made out of the circuit and used these clip leads. So everything to do with the power supply and the way it connects to the radio, substituted with something different. No change. Power supply fault, changed by substitution. No change. Bad feed-through capacitor, jumpered around it. No change. Screen bypass cap for the 2E26. The voltage is normal. There's no RF at that point. I think if that capacitor was bad, we wouldn't be seeing 200 volts here. So, problem with the tank coil, I don't see what it could be. And, you know, to test the modulation transformer further, I have to, there's a stupid light I couldn't find. Let's turn off light. Yeah, let me show you how this goes. Get out of there. Okay, let's find these terminal strips. Let's turn it around the other way. Just because I'm used to looking at it this way. Okay, so here's the bottom of the 2E26. And here, just can never get enough light on this for this camera somehow. Get myself oriented here. Here's this terminal strip right here. This black wire is the B plus being fed into the secondary of the modulation transformer. And the other wire from the secondary is this red one over here. This is the bottom of the bypass capacitor that goes into the final amplifier compartment, and this is the screen resistor. So, the resistance there is 300 and some ohms, which seems pretty normal. There's no short to ground from that winding. I'd have to lift one of these wires from the secondary to measure that any further. This red wire here on this terminal strip up here, can't see it for this wire, but right in here is the red wire coming from the primary of the modulation transformer. That's actually the center tap, the B plus feeding the center tap of the modulation transformer, and then on black wire comes up to the plate of this 6AQ5, and the other wire goes to the plate of, I can't see through the viewfinder enough to make sense out of this. Okay, here's the 16AQ5 here and the other 6AQ5 here. So I'd have to at least lift the red wire, the center tap from the primary of the modulation transformer there, in order to measure the transformer further, because the B plus is of the primary and of the center tap of the or the secondary and the primary are tied together in the radio to make it work. So I'd have to lift those to measure that any further to find out if there's a fault with the modulation transformer. But I don't believe there is. When I'm whistling to the mic, I can still see the modulator current rising just as it should. It's just that this we're only getting this 2-watt output, so the modulator's not even really getting the right load. So I've gone down this whole darn list. I don't know, let me get the schematic here. You know, I said earlier it's only a 2-tube transmitter, and it's true. 12 AT7, first half of the first triode is just a crystal oscillator, 8 meg crystal, 24, it's tripling, 24 meg output to the grid here. So I check this coupling capacitor just by jumping around it with another one, no change. So this is 24 megacycle or 25 megacycle energy here. This is the doubler, this triode, and another coupling capacitor here, jumpered around it, no change. This RF choke is okay. If this bypass capacitor was bad here, there's no RF there at this point. It might change the gain some. And there's another bypass cap here, probably the same value. There's 50 picofarads. So, you know, if I'm really going to get into it, I'll try to change these. But I think that these things were the ones that were buried down underneath this filter cap here. Remember, I showed you that there were a couple of capacitors and a resistor buried down underneath this thing. And here's where we're getting into the difficulty of this very compact layered wiring as it can be. You have to start taking stuff apart in order to service it. And so anyway, RF chokes are good. Plate load capacitors are good. All the way through. Coupling capacitors are probably good, which were the main suspects. Everything tunes normally. Now, if one of these bypass capacitors is gone bluey, it could change the stage gain here, and that could account for low drive, which is possible. But the grid drive looks like it did before on the meter. I didn't write down any numbers, but it looked pretty much the same. Now here, this says this is the diagram for the deluxe model. I've got 2E26. This is the capacitor that I'm worried about. This is that RF choke I showed you in the PA compartment, and this is that RF bypass cap from the top of the RF choke to ground. Now, if that thing is leaky, it'll provide an RF path from the tank coil right to ground, and that could drop the output way, way down. So I'm suspecting that may be the problem. It's just about the last place I've looked in. Like they say, it's always the last place you've looked. I did jumper around the relay contacts to the antenna to see if there was a problem there. No change. So, there you go. Now, another interesting facet of this radio is the construction. It's kind of hard to see, but there is a sub-chassis inside this box, a chassis, and it's a plate that's bent up in the front and bent up in the back. And it's not bent up in the sides. Maybe, yeah, there are little flanges there. And so most of this circuitry was all wired before it was put in the box. And then, after it was put in the box, they connected up the controls. And the controls are soldered to the wiring, and you know, the controls are fixed to the chassis, and I don't think there's any way in hell that you could ever get that chassis back out of the cabinet without major deconstruction. I think you'd have to unsolder all this oscillator wiring, crystal socket wiring, volume control wiring, It would just be a nightmare. So here you go. I think maybe I'll pull out a well-made mobile rig like a Moro and show you by comparison how they've built an even more complex radio in a very small box and yet managed to make every inch of it serviceable. Every inch. So there we go. So I'm stuck with this conundrum now. I don't know, I'm used to working on transmitters. And you know, this is just a fairly simple transmitter. It's really right back to basics. It's just all built into the size of a teacup. And it's the mechanical aspects of it make it rather difficult. And particularly in the case of this, let me get this light on here. And this little disc capacitor down here, I think you can see that disc capacitor. You can just, looking at the edge of it vertically, that little brown disc ceramic capacitor is the suspect. And how the heck am I ever going to get to that thing? At the very least, I got to take out the tube, and I think I've got to take out the TR relay, just to get in there to get access to that little disc ceramic capacitor. And about the only thing I can do is just shotgun it. It's so much work to get in there that, and the thing is soldered. Well, you know, the ground end is soldered to the chassis, and there's no way in hell that I can get in there with a big gun and solder to that chassis like that again. So I don't know. It's a nightmare. It's going to take some serious thinking about how to deal with this thing. And whether I want to go through that or not, make sure I've really eliminated all the possibilities. If the problem's back in the oscillator and I tear this all up, I'm going to feel pretty stupid. Well, this is one of the problems that you have with radios where you lack documentation, is that you don't have, for instance, a nice voltage chart. where you can take an RF voltmeter and put it on the grid and the plate of that oscillator tube and say, okay, nifty, we got the voltage that we want there. The stage is working right. You just kind of got to go by guess and by God. I guess I can go and look for some typical operating, if I can find some typical operating conditions for a 12AT7. Is it AT7? Yeah, 12AT7 dual triode operating as an oscillator and doubler. If I can find some values there, which I might find in the tube handbook, I might get some ballpark values and get a better idea there of what might be happening. But I'll tell you, this is turning into one annoying little pissant. Usually, I can go right to the heart of a problem like this in a matter of minutes, and this one is not proving to be that way. So it's stretching my patience some. So that's it on the Black Widow at this time from W6WUH. Thanks for watching. Thanks for listening.